sort of looks like these curved structures. These curved things, however, are actually cartoon representations that are roughly to scale, well, to each other, not to the size of the Earth, of the Van Allen belts. So the red is the inner Van Allen belt, the gray is the outer one. The orbit we're in actually takes us through a fairly thick part of the inner Van Allen belt on essentially every orbit. The orbits are about 97 minutes. So every 45 minutes or so, it's going through quite a bit of radiation. And as a result, the radiation environment on the Orion spacecraft is about 15 times the dose rate that's received at the International Space Station. So it's a pretty high radiation environment, yet we use commercial electronics. These are not radiation hardened. We did test virtually all the electronics to see that they would survive the kind of doses that this would get in 6 months. It's not predicted to last for 4 years, but there you go. It's still, most of it's still working, and it still does regular communications with us. So the biology gets exposed to about 1.3 gray. If you know radiation doses, that means anything to you. That might be typical if you've got local radiation in a limb or something. You might have a kind of localized dose. You wouldn't want it over your whole body. And most of that is trapped protons that are part of this inner Van Allen belt. The organics, which are hanging out there in space to get the direct solar UV radiation over as long as 18 months, get something like 3,600 hours of direct sun exposure. And they also get a lot of ionizing dose because they're not as well shielded as the others. So they get 55 gray, which is quite a significant dose. We have some onboard rad FETs to measure the radiation dose. A number of other sensors too that are very standard. Some MEMS, off-the-shelf devices, some non-MEMS. A MEMS pressure sensor for Motorola, temperature sensors for analog devices, relative humidity sensors that come